Video, I'm going to show you how to do AQA A-Level Maths Paper 1, June 2018, question 9. My name is Sunil Tanna. I'm an author and tutor. Details on the card. I'm available for one-to-one tuition, both online and in person. I live in Buckinghamshire, England. Question 9. An arithmetic sequence has the first term A and common difference D. The sum of the first 36 terms of the sequence is equal to the square of the sum of the first 6 terms. Show that this formula is true. 4a plus 70d equals 4a squared plus 20ad plus 25d squared. Okay, the sum of a sequence is given by this formula. The sum of n is equal to n over 2, an arithmetic sequence of course, is 2a plus n minus 1 times d. Now, the sum of the first 36 terms would therefore be given by 36 over 2 times 2a plus 35d. And what we know is that's equal to the square of the sum of the first 6 terms. So that's equal to, all squared, first 6 terms is 6 over 2 times 2a plus 5d. If you now simplify that, it will be 18 times 2a plus 35d is equal to 3 over 2 squared is 9 plus 2a plus 5d squared. We can now expand the square on the right hand side of this. So we can have 18 times 2a plus 35d is equal to 9 times 4a squared plus 20ad plus 25d squared. Now all we need to do is divide by 9 both sides, so we will now have 2 times 2a plus 35d is equal to 4a squared plus 20ad plus 25d squared, and then expand our brackets on the left hand side, which will give us 4a plus 70d is equal to 4a squared plus 20ad plus 25d squared, which is the result we wanted. The second part of the question now, it says, given that the 6th term of the sequence is 35, find the smallest possible value of a. Well, we know that the 6th term is 35. The 6th term is given by a plus 5d, and that's equal to 25. So rearranging that, we know that 5d is equal to 25 minus a. Now, if we look at the formula that we had in the previous part of the question, it was 4a plus 70d is equal to 4a squared plus 20ad plus 25d squared. And we'll notice that there are a lot of occurrences of d in there that we can substitute. It's actually easier to substitute for 5d, so we could write this as 4a plus 14 times 5d is equal to 4a squared plus 4a times 5d plus 5d in brackets, all squared. So if we substitute for 5d, it will now be 4a plus 14 times 25 minus a is equal to 4a squared plus 4a times 25 minus a plus 25 minus a, all squared. Now we can open out the brackets, expand the brackets, and hopefully solve the equation. So on the left hand side, we are going to have 4a plus 375 is 14 times 25. 350 is 14 times 25. Minus 14a is equal to 4a squared, and then 4a times 25 is 100a and 4a times minus a is minus 4a squared, and then we've got to expand this last bracket here, which will be 625 minus 50a plus a squared. And now we can collect the terms, like terms. So the left-hand side becomes 350 minus 10a, and the 4a squareds cancel out, and we've now got a squared plus 50a, because we're combining the 100a and the minus 50a, plus 625, which is obviously a quadratic equation. We can bring everything to the right-hand side. So that would be 0 is equal to a squared. So add 10a to both sides will give us 60a. Take away 350 from 650 gives us 275. And we now have a quadratic equation we can solve. You can either solve it using the quadratic formula or by factorizing. Factorizing is a little bit tricky. You need to find two numbers that multiply to make 275 and add up to make 60. Obviously, the quadratic formula is relatively easy, especially if you have that function as a built into your calculator. I can factorize this one though. It's actually a plus 5 and a plus 55 are the two factors, which tells us that a is equal to minus 5 or a is equal to minus 55. We want the smallest possible value of a, so reject a equals minus 5. So answer is a is equal to minus 55. And that's question 9 complete.